Okay, we're going to do a semester 1 exam, starting off with the calculator free. Question 1. C1 and C2 are chords in the same circle. Let P be the statement that chords C1 and C2 have equal lengths, and Q be the statements that chords C1 and C2 subtend equal angles at the center. Write in words the negation of P. Well, the negation of P literally means like the direct opposite of P. So if P says chords C1 and C2 have equal lengths, then honestly the direct negation of that is chords C1 and C2 do not have equal lengths. Okay, so that's a really straightforward one marker. Chords C1 and C2, C1 and C2 do not have equal lengths. Okay, write in words the meaning of this. Now everyone knows that this means if P then Q. Alright, this means if P then Q. But we have to relate it to the actual concept. So if P then Q, so if chords C1 and C2 have equal lengths, then Q, meaning therefore chords C1 and C2 subtend equal angles at the center. So we have to write if P then Q, but in words. So we're going to write down that if chords C1 and C2, if chords C1 and C2 have equal lengths, then the chords subtend equal at angles at the center. So then chords C1 and C2 subtend. The exact word that they use is angles at the center. So they subtend equal angles at the center. That's it. Write symbolically the converse of this. Now we know what the converse means. Converse just means if Q then P. So the converse of if P then Q, just swap them around. It means if Q then P, but they said write it symbolically. So symbolically, you just write the exact same thing, but you swap the P and the Q around. So symbolically, it means if Q, then P. So if Q, then do your like double arrow kind of thing. So that would be this and this. So yeah, that means if Q, then P. All right, that's what it means symbolically. Write in any form the inverse of this, in any form. All right, that's in any form means we have a lot of different options. So you could keep it very easy and just write. So I hope everyone remembers the inverse of if P then Q is if not P, then not Q. So one of the easy things you could write down is if not P, then not Q. That will do the job. Alternatively, you could have written down if not P, so the symbol for if not P is this. So if not P, then not Q. I'll just copy the symbol around. So if not P, then not Q. Alrighty, and that's not the only symbol for if not. There is another symbol if you're familiar with it. The symbol looks like this, okay? It's like this. That just means if not. So if not P, then not Q. So that would be another way of writing it. If not P, then not Q. So same thing, that just means not. So lots of ways of writing not, but this is one common way of writing not. So if not P, then not Q. Or you could have actually just like related it to the question itself. Because it said in any form, you could have related it to the question. So the question basically is, if chords C1 and C2 do not have equal lengths, then they do not subtend equal angles at the center. That was also an acceptable answer. If chords C1 and C2 do not have equal lengths, C1 and C2 do not have equal lengths, and then chords C1 and C2 do not subtend equal angles at the center. Then chords C1 and C2 do not subtend equal angles at the center. Easy as that. Okay. Write in any form the contrapositive of if P then Q. All right, now we know the contrapositive is, all right, I like to think of the contrapositive as like the, I like to think of contrapositive as pretty much the converse of the inverse. Okay, that's how I like to think of it. It's the converse of the inverse. Now, obviously, the inverse of this is if not P, then not Q. And then if you do the converse of that, it's if not Q, then not P. So they're very happy with a statement that says, if I was to use these symbols, so if not, so I want to do the converse of it. So the converse of it is if not Q. So this is, think about it, this was the inverse. So now I just want to do the converse of the inverse. Converse means swap these two around. So really, one very acceptable answer is if not Q, then not P. If not Q, then not P. You don't have to use that symbol for if not. You can use a symbol such as like P dash, okay, so, or Q dash. So you could have easily said if not Q, then not P. That's also acceptable. Or you could have done the English version as well. So the English version of this is if chords C1. So I'll just show you how it really is just the converse of the inverse. Remember, this is the inverse. So look what I'm about to do. So if chords C1 and C2 do not subtend equal angles at the center. So if chords C1 and C2 do not subtend equal angles at the center, then chords C1 and C2, then chords C1 and C2 do not have equal lengths. Alrighty, then chords. So you can clearly see that the contrapositive is the converse of the inverse, and I'm sure everyone knows that if the original statement is true, then the contrapositive must be true. The question says, state whether the contrapositive is true or false. Now, we know the original statement is true. It's one of our circle theorems that if chords are of equal lengths, then they must subtend equal angles at the center. You can prove that using like a congruency proof. So pretty much, as it's only worth 2 marks, you don't have to do a full-on congruency proof. So I'll just say as the original statement is true, as the original statement is true, the contrapositive statement is also true. The contrapositive statement is also true. Okay, pretty much they're like logically equivalent. The contrapositive is logically equivalent to the original statement. All right, and just PS, not that the question is asking for it, but just PS, I'll prove to you why it's true. So here's a circle. Let's draw 2 chords of equal length. So there's one chord right there and another chord right here. They look equal-ish in length. It doesn't have to be super to scale. So there you go. We have 2 chords that are of equal length. This and this are of the same length. Okay, chords of equal length. And I have to prove that they subtend equal angles at the center. So let me just draw the center somewhere around about there-ish. So we have to prove that they subtend equal angles at the center. And look how I do it, okay? Not that the question is asking for it at all, but it is a nice, pretty easy one, but still nonetheless a nice proof. Okay, so what do we have? We obviously have these 2 sides that are the same. I'll do them in different colors so you guys can really see it. I'm not going to write it all out because the question is not asking us to write it out. But we obviously have this equal to this because it's given. Then we have technically this equals that because it's the radius. And at the same time, this also equals that because it's also the radius. So that was radius, and then obviously that was radius, They're all radius. So you have side, side, side. These 2 triangles are congruent to each other because of side, side, side. And if they're congruent to each other, then correspondings of congruent triangles are equal. So there you go. You've proven that if the chords are of equal length, they do subtend equal angles at the center. So that was the proof behind it. Okay? Not that they wanted you to do the proof. Question 2. Use the inclusion-exclusion principle to determine how many integers between 1 and 131 inclusive, that's important, inclusive, are divisible by 2, 3, or 8. All right, I'm going to keep it very simple. I'm just going to figure out, we know what the inclusion-exclusion principle for 3 events is. The inclusion-exclusion principle for 3 events, the number that are in A or B or C are the numbers in A and, are the numbers in A plus the number in B plus the number in C. Then you minus away every single double intersect. So we minus away A and B, we intersect minus away A and C, and we minus away B and C, and then lucky last, we add the triple intersection, so A and B and C. So that's how we do inclusion-exclusion principle for 3 events. So in this case, if I want to know the numbers that are divisible by 2 or 3 or 8, I do the numbers divisible by 2 plus the numbers divisible by 3 plus the numbers divisible by 8 minus away all the double intersects. Okay, so what's the double intersect? Divisible by 2 and 3 means divisible by 6 minus divisible by 2 and 8. Well, if you're divisible by 2 and 8, the LCM of 2 and 8 is just 8, so minus the numbers divisible by 8. And then minus away the last double intersect, which is divisible by 3 and 8. The LCM of 3 and 8 is 24. So minus the numbers divisible by 24, plus the triple intersect. The triple intersect is divisible by 2, 3, and 8. Now, what's the LCM of 2, 3, and 8? The LCM of 2, 3, and 8, well, the LCM of 2 and 3 is 6, and the LCM of 6 and 8 is 24. So it becomes plus numbers divisible by 24. And now this question becomes very odd. All right, it didn't click to me straight away, but by writing it this way, it's clicked to me that, look, this is minus numbers divisible by 24 plus numbers divisible by 24. So that just cancels out. And this is numbers divisible by 8 and minus numbers, and this is plus numbers divisible by 8. So really, this question has really just become numbers divisible by 2 plus numbers divisible by 3 minus numbers divisible by 6, which is so odd. But then it actually makes perfect sense. I'll show you why it makes perfect sense. If I was to draw a bit of a Venn diagram, now, do you realize that these are 3 circles? Obviously, they're 3 different events, but look at this. I mean, obviously, there's divisible by 3. So if I do the event of divisible by 3 in like green, so divisible by 3 is like this. All right, or divisible by 2 or divisible by 8. But then I've just realized that if you're divisible by 8, you are definitely divisible by 2. Everything that's divisible by 8, other way around. Everything that's divisible by 2, anything that 2 goes into it, like I said, anything that 8 goes into it, 2 definitely goes into it. Anything that 8 goes into it, 2 definitely goes into it. So what I'm trying to say is if this is 8 goes into it, if 8 goes into the number, you can think of it like this. This is 8 going into the number. That's the event that 8 goes into the number. So I'll write 8 goes into the number and 3 goes into the number. But then if 2 goes into it, then 2 goes into it. If I did that in a completely different color, if 2 goes into it, well, definitely, if 2 goes into the number, then it would be like this. That's what it would be like if 2 goes into the number. It would look like something like that. And that's the point. Okay, so really it felt like it was the union of 3 events. We want the probability of divisible by 8, or divisible by 3, or divisible by 2. But then really, that just means divisible by 2 or divisible by 3 because this is a multiple of it, okay? That's what, it didn't click to me straight away, but it's clicked to me now. That if you're divisible by 2, or you're divisible by 8, if you're divisible by 8, or you're divisible by 2, then that just means you're divisible by 2. Because everything that's divisible by 8 is divisible by 2. So really, I know it felt like 3 events, but really, if it's divisible by 2, 3, or 8, it's divisible by 2 or 3. So really, the question was just numbers that are divisible by 2 or 3. That's really what the question came down to, numbers that are divisible by 2 or 3. And numbers that are divisible by 2 or 3 are the numbers divisible by 2 plus the numbers divisible by 3 minus numbers divisible by 6, which is actually what we ended up with. That's because that's the formula for, that's the inclusion-exclusion principle for 2 events. If you're divisible by A or B, you're either divisible by A or you're divisible by B, minus away numbers that are divisible by A and B. So yeah, it didn't click to me that it was 2 events straight away, but as soon as I did this, I realized that things were crossing out and then it did become 2 events. So now the rest is easy. Now I really just have to, figure out numbers that are, first of all, I guess, divisible by 2. So numbers that are divisible by 2 out of what? 1 to 131 inclusive. So I've got to do 131 divided by 2, and I got to round down. Okay, I got to round each of these down. So 131 divided by 2, but I'm going to round that down. 131 divided by 3, but I'm going to have to round that down as well. And then minus 131 divisible by 6. And even that one I'm going to have to round down. Each of these individual things I'm going to have to round down. Okay, so first of all, what is 131 divided by 2 rounded down? So 131 divided by 2 is 65. 131 divided by 3, so 4 3s are 12. Carry the 1, 11, and then 3 3s are 9. So yeah, 43, remainder 2, but we have to round down, so that rounds to 43. And then 131 divided by 6, 2 6s are 12. Remainder 1, 21, remainder 5. But each of these numbers we have to round down, okay? It's important that you understand that each of these numbers needs to be rounded down. So what I have is 65 plus 43, take 21. 65 plus 43, take 21 is 87. So there you go. 87 numbers are divisible by 2, 3, or 8. Cool. Alrighty, next question. Two vectors, a equals 6i, take 8j, and b equals I, take 3j. Alrighty, so two vectors are given. Determine the vector projection of a onto b. So hopefully everyone remembers the formula. The formula for vector projection of a onto b is a dot b divided by magnitude of b squared times vector b. Alrighty, that's all it is. Alrighty, so a dot b, a is 6 negative 8, b is 1 dot 6 negative 8 dot 1 negative 3 divided by the magnitude of b squared. Magnitude of b squared is 1 squared plus 3 squared times vector b, which is 1 negative 3. Now you just have to do the dot product correctly and not mess up the dot product. So that would be 6 plus 24. 1 squared is 1, 3 squared is 9, so 10 times 1 negative 3. 6 plus 24 is 30. 30 divided by 10 is quite simply 3. So we have to do 3 lots of 1 negative 3. That's all we got to do. 3 lots of 1 neg 3. 3 lots of 1 neg 3 is 3 negative 9. Okay, simple as that. 3 or negative 9. Perfect. Alrighty, next one. Vector C is xi plus yj. It has twice the magnitude of A. It's twice as big as A. And it's perpendicular to B. Fine. Twice the magnitude of A, perpendicular to B. So let's start off with the fact that it's perpendicular to B. Alrighty, what is a very quick vector that's perpendicular to 1 neg 3? How do you find a vector that's perpendicular to 1 neg 3? Well, you want something where 1 neg 3 dot some vector gives you 0, right? You want something where you dot it and you get 0. All right, the easy thing to do is just flip the fraction, change the sign. Flip the fraction, change the sign of one of them. Sorry, flip the fraction and change the sign of one of them. So this becomes neg 3, 1. It's not really even a fraction, to be honest, but flip it and change the sign of one of them. So you can, I'll just change the sign of the negative 3 into a plus 3. So it literally is 3, 1. Think about it. Is the vector 3, 1 perpendicular to it? Yes, 1 times 3 plus negative 3 times 1 is 0. And this kind of makes sense. It's kind of like methods and when you do gradients. Isn't the gradient of two things that are perpendicular, aren't they the negative reciprocals of each other? So you can see all I've done is flipped it around and changed the sign. Okay, it's kind of like what we do in methods. But the point is, you had to find a vector perpendicular to I take 3j. And a vector perpendicular to I take 3j is the vector 3, 1. Okay, that's a very nice, easy vector. The vector 3, 1. Alrighty, now I've got to do the rest. Okay, so I've got a vector. I've satisfied the criteria that it's perpendicular to B. The only thing is I need to make sure it's twice the magnitude of A. I've already got this vector. I just have to make sure it's twice the magnitude of A. So let's just work out what is the magnitude of A. It's a Pythagorean triple. The magnitude of A is square root of 6 squared plus 8 squared No need to write the negative, so square root of 8 squared plus 6 squared is 10. The magnitude of vector A is 10. Now that I know the magnitude of vector A is 10, so what do I want? I want something that's twice the magnitude of A and perpendicular to B. Well, this already is perpendicular to B. I just need to make sure it has a magnitude double 10, which is 20. And the easiest way of doing that is get the vector that's perpendicular to it. First, divide it by how big it is, so that it's a unit vector. So we'll divide it by 3 squared plus 1 squared. Once you've done that, then we can times it by the vector by 20. Then we can times it by 20, because this turns it into a unit vector, and then timesing it by 20 makes it 20 units big, which would be twice the magnitude of A. 3 squared is 9, 9 plus 1 is 10, so what we really have is 20 on root 10. 20 on root 10 times 3, 1. 20 on root 10 times top and bottom by root 10, so that's 20 root 10 on 10, so that simplifies out quite nicely, times 3i and 1j. That's 2 root 10 times 3i plus 1j. 2 root 10 times 3i plus 1j. So that really is 6 root 10 and 2 root 10. There you go. That satisfies the criteria. It's perpendicular and it's twice the magnitude. Now, to be fair, it did say the value of the constants, and it just said perpendicular to B. Nobody said in the same direction. So I know 3, 1 was perpendicular to B, but what about negative 3, negative 1? Think about it. Something like this and something going in the exact opposite direction. If it's exactly the same size going in opposite direction, it still would be perpendicular. So either one of these could be C, because either way it's going to be perpendicular to B, and they'll both be the exact same size of 20 units big. So really, I know it says C is xi plus yj. This is what C is equal to. So pretty much one option is that x is 6 root 10 and b is, y is the corresponding value, y is 2 root 10. So that is option 1. Option 2 is the negative version of that. Or x is negative 6 root 10 and y is negative 2 root 10. Those are your two possible options. Okay, those are the two options that it takes. Okay, so nice questions. Make sure you listed both of them. Okay, it was important that we listed both those options. Alrighty, cool. Next one. Crossed quadrilateral OABC is shown in the diagram. The midpoints are as shown. Midpoints of sides OA, AB, BC, and CO, P, Q, and R. Okay, so the midpoint of OA is P. Midpoint of OA is P, so I'll put P somewhere randomly here. Midpoint of AB is Q, so I'll put that somewhere here. Midpoint of BC is R, so somewhere here-ish. And midpoint of CO is S, so that would be somewhere here-ish. So first of all, it says draw quadrilateral PQRS. There you go, that's quadrilateral PQRS. All right, close enough. Okay, close enough to something like that. All right, cool. Yeah, good enough. We'll do the job. All righty, determine expressions for OP, OS, OQ, and OR in terms of A, B, and C. All righty, and then prove that these form a parallelogram. All right, well, kind of look like a parallelogram. Maybe if I'd drawn it a bit more accurately, it kind of does look like a parallelogram, but we really got to like mathematically prove that they form a parallelogram. All right, so what do I have to figure out an expression for first of all? OP. All right, how will I get from O to P? Well, that's actually really easy, because isn't OP just halfway from O to A? That's what OP is. It's just halfway from O to A. So OP is half of O to A. So that's just half A. All right. They also want OQ. How will I get from O to Q? To get from O to Q, I'll go from O to A and then A to Q. I'll go from O to A plus A to Q. And A to Q is really just half of A to B. And now it's easy, because how can I write AB? Remember, I've got an origin. Everything is with respect to the origin. So another way of writing AB is just really just OB take OA. it's really just OB, take OA. OA is just OA, so that's just 1 OA, and then take away half. If I expand it out, it's going to be take away half OA. So I really have half OA plus half OB, which is really just half A plus B. Half A plus half B. So I can either write half bracket A plus B or half A plus half B. All right, what's next? O to Q. How will I get from, oh no, that was O to Q. Oh, which one have I missed? O to S. I did O to P, there's an O to S. Oh, that's even easier. O to S is just halfway from O to C. That was a very easy one. O to S is just halfway from O to C. Halfway from O to C is just C. That's OS. What else do we have? We have OP, OS, OQ, and lucky last, OR. That's a little bit messy, how to get from O to R. I'll go from, what do I have expressions for? I've got lots of ways of doing it. I'll just go from O to B and then B to R. I could have gone O to C to R. I could have gone O to B, B to R, but I've just, I got to go from O to A to R, but, well, A to R is hard, but yeah, anything along here would have been okay. So I'll go from O to B and B to R. Okay, O to B plus B to R. OR is O to B plus B to R. I'm sure the class appreciates that B to R is halfway from B to C. B to R is halfway from B to C because it's the midpoint. Okay, we literally got told that R was the midpoint of BC. Okay, and now it's easy. We have an origin, so we do everything in terms of the origin. Another way of writing BC is just OC take OB. This is really just OC take OB. So what I really have is B plus half C take half B. Alrighty, or I could have just said like OB take half OB. Doesn't matter which order you say it in. So at the end of the day, we have a half B plus a half C. All right, I did exactly what they did for my 4 marks or 3 marks. I've got expressions for those things. Prove that the midpoints of the cross quadrilateral form a parallelogram. So these are the midpoints of the cross quadrilateral. All right, we have to prove that they form a parallelogram. There's lots of ways of proving geometrically that things are parallelograms. Lots and lots of ways. But one of the easiest way to prove something is a parallelogram, is you prove one set of opposite sides are equal in length and parallel. If you can prove one set of opposite sides, are equal in length and parallel, that is a very, very easy way to prove something is a parallelogram. Just prove one set, any two. Look, for example, if I draw a random one of this, and then I just copy paste the exact same thing like somewhere here, for example, somewhere random. And now I just connect it up. So I connect this up like here. And I connect this up here. There you go. There's a parallelogram. So all you had is one set of sides that were equal in length. So this was equal to this. And at the same time, it was parallel. And as soon as you have one set of opposite sides that are equal in length and parallel, it proves that it's a parallelogram. So I just have to pick one set of opposite sides. So I'll go with PQ and SR. PQ and SR. And what's so good is I can use the information from the previous question. Isn't PQ just OQ take OP? And I have expressions for OQ and OP. There's my expression for OQ, and there's my expression for OP. This is my expression for OQ, and then I've got an expression for OP is just half A. So OQ first minus our OP, so OQ is this, and OP we agreed was half A, and then the A is just cross out, so PR is just half B. Alrighty, that is the vector PQ. Alright, what's opposite PQ? SR. So again, I use my answer from the previous part. SR is just OR take OS. I'm pretty sure we came up with expressions for OR and OS. Yes, we did. There's OR, there's OS. So it's just this one, take away that. It's just half B plus half C, take away half C. Half B plus half C, take away half C. The c's cross out, and you're left with half b. Amazing! You have just proven that PQ is half b and SR is half b. We have just proven that therefore the vectors PQ equals the vector SR. And if the two vectors are equal, you've proven two things. You've proven that therefore the magnitude of PQ equals the magnitude of SR, and you've also proven that PQ is parallel to SR. Therefore, you've proven that opposite sides, one set of opposite sides in quadrilateral PQRS, are equal. One set of opposite sides, I keep forgetting to write the whole thing, one set of opposite sides in quadrilateral PQRS are equal in length and parallel. And that is what you need to prove something is a parallelogram. Isn't that what I said earlier? One set of opposite sides are equal and parallel. So therefore, PQRS is a parallelogram. PQRS is a parallelogram, which is exactly what we were required to prove. We were required to prove that the midpoints of the sides of a crossed quadrilateral, so these are the midpoints of a crossed quadrilateral, PQRS, that they also formed a parallelogram. Nice and easy. Alrighty, question 5. Let A equal 3, 5, B equal 3, neg 2, etc., etc. 4A plus 2C, very easy stuff. So that's just 4 lots of 3, 5, plus 2 lots of 4, neg 5. 4 3s are 12, plus 8 is 20, 4 5s are 20, take away 10 is 10. So there you go, that's just simply 20I take 10J. The magnitude of C take B, well, first we'll just work out what C take B is before I work out its magnitude. C take B is 4, negative 5. Take away 3, negative 2. 4 take 3 is 1, negative 5 take 2 is negative 3. The magnitude of C take B, therefore, is square root of 1 squared plus 3 squared, which is root 10. All right, another vanilla question. Given that A is lambda B plus mu C, determine the value of the constant lambda and the value of the constant mu. A is lambda B plus mu C. If A is lambda B plus mu C, that means A, which is the vector 3, 5, the vector 3, 5 can be written in terms of the vector 3i plus 5j is lambda lots of B, which was 3, neg 2, lambda lots of 3, negative 2, plus mu lots of C, which is 4, negative 5. And now it's easy. Let the i's equal, let the j's equal. So if I let all the i's equal, if I let all these i's equal, all right, if I like color it in, so I let all the i's equal to each other and let all the j's equal each other. So if I let all the i's equal each other, the equation that I get is 3 equals 3 lambda plus 4 mu. And that's kind of like my equation number 1. I'm pretty sure will be a simultaneous equation. And 5 equals minus 2 lambda, take 5 mu. That will be my second equation. I can use substitution or elimination. I'll probably just use elimination. I'll times this equation out by 2. 6 equals 6 lambda plus 8 mu. That's my new equation 1. Times this one by 3, so 15 equals minus 6 lambda, take 15 mu, that's equation 2 prime. Now I can use elimination because now they match. You can clearly see that now that they match, now you can see that we have 6 lambda and negative 6 lambda, so all the lambdas match. So pretty much we'll do equation 1 prime plus equation 2 prime. 6 plus 15, 21. Lambdas cancel out, and 8 plus minus 15 is minus 7 mu. So therefore, mu is minus 3. Okay, so that's my starting point. Mu is minus 3. Chuck it into either equation. I'll chuck it into, I don't know, equation 1. 3 is 3 lambda plus 4 mu. We just worked out that mu was minus 3. 3 is 3 lambda, take 12, bring the 12 to the other side. Lambda is 5. And that's all the question said they wanted. They wanted the value of lambda and mu, such that A is lambda B plus mu C. Next question. An isosceles triangle. ABC is an isosceles triangle in which BA is BC. All right, let's just draw this. BA is equal in length to BC. So that's like B is the common thing, isn't it? So BA equals BC. M is the midpoint of AC. M is the midpoint of AC. Alrighty, so it's the middle, so important that we know it's the middle. Show that BA plus BC is 2BM. Alright, now, yeah, a little bit challenging because they're not telling us what vector to like equal what, but what you have to do in questions like this, in a triangle, you must define 2 of the sides. Don't define 3, that's too many, and don't define 1, that's not enough. So we're going to define 2 of the sides. So I'm going to, for example, I'm going to let AB be the vector A. So AB is the vector A, and I'll let AC be the vector C. AC is going to be the vector C. All right, so now I'm just going to come up with expressions for the left side, and I'm going to come up with expressions for the right side. So the left-hand side is BA plus BC. Well, BA is just negative AB, and B to C, how will I get from B to C? So I'll go from B to A, and then I'll go from A to C. So really what I have is minus AB minus another AB, so 2 minus 2AB plus AC, and we just agreed we're letting AB be A. So what I have is minus 2A plus C. So that's the left-hand side. That's BA plus BC. The right-hand side is 2BMs. All right, how will I get from B to M? So that's B to A plus A to M. Yes, think about it. B to M is B to A and then A to M. And then A to M is halfway from A to C. This is halfway from A to C. Then I'm going to times that all by 2. So that's 2BA plus AC. And really 2BA is negative 2AB plus AC. And now where am I at? I'm at minus 2A plus C. Great, that's minus 2A plus C, that's minus 2A plus C. Therefore, left-hand side equals right-hand side. And basically, yeah, therefore we've proven that the vector BA plus BC equals 2BM. Cool? That's it. Pretty easy proof. Next one. Ooh, 5 marks. Maybe this one's a bit harder. Alrighty. ABCD is a parallelogram. Cool. M is the midpoint of D's. Okay, let's just draw it. A, B, C, D. Just go around clockwise or anti-clockwise, something like that, okay? Don't skip around. Don't do like A. It's never A, B, C, D. It's not like that. You have to keep going around in a circle. So if I start with A here, then it's like A, B, C, D. ABCD is a parallelogram. M is the midpoint of DC. All right, M is the midpoint of DC, so that's equal. Diagonal DB intersects AM. Oh, okay. Diagonal DB intersects AM. Alrighty, so let's just extend AM. So that's AM. Diagonal DB. Oh no, I don't know why I expanded it. So that's DM intersects diagonal DB. So diagonal DB is this one right here. Diagonal DB intersects AM at Q. Okay, yep. So that AQ is H lots of AM. AQ is a fraction of HM. I agree, AQ is a fraction of HM. And DQ is K lots of DB. Yes, DQ is a fraction of DB, DQ is a fraction of... Okay, I hope everyone remembers that H and K are both less than 1. They're between 0 and 1. Because AQ is a fraction of AM, and DQ is a fraction of DB. So they're both less than 1. Use a vector method to determine the value of the constant H and the value of the constant K. All right, very, very, very vanilla question. An extremely vanilla question. Alrighty, now it's a parallelogram. So in a parallelogram, we have to define 2 sides. So what I'm going to do is I'm going to let AB equal B. And I'm going to let AD be the vector D. So this is the vector B, and if that's B, this is also B because it's a parallelogram. And if AD is D, then also BC is D as well. So I'm going to start off with that. Alrighty, where to begin? Now, obviously, you want to use this information. Alright, somewhere along there, you want to use this information. So look what I do. Alright, it is a bit unique because they don't hold your hand. Okay, this question doesn't hold your hand. It kind of just makes you jump straight to there. Now, notice what I'm going to do. I've got an expression for AQ. And, well, yeah, somewhat of an expression for AQ. And then they have DQ. Now, you'll notice that AQ and DQ obviously have Q in common. So look what I'm about to write down next. I'm going to write down that AQ, I'm going to write down that A to Q plus Q to D is the same as A to D. All right, it is the same as A to D. So A to Q plus Q to D is the same as A to D. And the point of these vector proofs, yeah, think about it, flying from America to Qatar and Qatar to Dubai is the same as flying from America to Dubai. And the point of these proofs is you have to use all the information. Alrighty, there are 3 pieces of information. I'll tell you what 3 pieces of information we have. We have this one, we have this one, and we have the fact that M is the midpoint. Alright, those are the pieces of information that I have. I've got to use all pieces of information. So what do I write down instead of AQ? I write H lots of AM. I write H lots of AM. Instead of QD, I write down, now this is DQ. So QD would be the opposite of this. So QD would be like minus DQ. So then I'm going to write minus K lots of DB. Minus K lots of DB equals AD. And I know that AD is just D. So now H lots of AM. What is AM? AM is A to D plus D to M. Okay, we're going to do a semester 1 exam, starting off with the minus away K lots of dB. All right, what's dB? How will I get from D to B? D to B is like D to A plus A to B. So D to A plus A to B equals AD. Alrighty, and where does that get us at now? So we just have to replace dm with what it is. dm is half of dc. Okay, dm is half of dc. So I replace dm with half dc minus k lots of dA. Yeah, I've got an expression for dA. AB, yes, I've got an expression for AB equals AD. All right, time to replace it with the letters. Time to replace it with the fact that AB is B and AD is D. So AB and DC are both B, and AD and BC are both D. So let's use that knowledge. So what we have is H lots of, now what is A to D? A to D is D. D to C is B. Minus K lots of D to A was, well, A to D is D, so D to A is negative D. And A to B was B. And then A to D is just D. Alright, if I expand the whole thing out, what do I have? And remember, guys, I mean, I've got a very bad habit of not writing arrows on my vectors. So D, B, these have arrows on them. The K and the H don't because they're not vectors, they're constants, okay? Alrighty, so anyway, if I expand it all out, we have H lots of vector D plus half H lots of vector B plus K lots of vector D minus K lots of vector B is D. And now you let the D's on, just like you let I's on the left equals I's on the right and J's on the left equal J's on the right, I'm going to let the D's on the left. That's a D, that's a D, and that's a D. D's on the left equal D's on the right. So what we have is H lots of D plus K lots of D. That's just equal to 1 because you have 1D. So I've let all the D's equal. Time to let all the B's. The B's on the left equal B's on the right. So that's a B on the left, that's a B on the left. And there's technically no B's on the right. So there's technically like 0 B's on the right. So then I'm able to write down half H, take K, equals 0 B's on the right. That's your second equation. Now I'm going to simultaneously solve for H and K. Okay, that's all it comes down to. Simultaneously solving for it. So literally what I have over here, I guess at the end of the day, is K is half H. If I bring K to the other side, replace K with half H over here. So I've got H plus half H equals 1. 3 on 2H equals 1. So h is 2/3. And if h is 2/3, and I know for the fact that k is half of that, or you can say h plus k is 1. You can either sub 2/3 into here or 2/3 into there. So k is half of h. So half of 2/3 is 1/3. So there you go. That's h and k. Alrighty, I'd say that's a difficult question because they didn't hold your hand. Okay, they didn't give you like separate bits to work out, but it's a very, very classic vector proof. If you've done the proofs in the OT textbook, you should be very familiar with that. Okay, OT textbook, not the revision series, but the OT textbook is great for vector proofs. So this is one of the classic vector proofs where you simultaneously solve for two of the variables using all the information that's been given in the question. Okay, so that's why it was worth 5 marks, because they didn't hold your hand. All right, question 7. Points A, B, and C lie on the arc of a circle with center O as shown. Yep, okay, cool. Chord A, okay, they all lie on the arc of a circle with center of the origin. Chord AC, yep, that's AC, intersects OB at point D. Alrighty, so that's a chord, that's just the radius, that's not even a chord, so that's a radius, intersects. When angle ABC is 122 degrees, okay, so let's put that on there. Angle ABC is 122 degrees. And angle BCA is 33 degrees. So angle BCA is 33 degrees. Determine the size of angle BDC. We want the size of angle BDC. So we're interested in this one right here. Okay, so you have to see what rules to use, okay? Now, obviously, first of all, remember, it's not even a cyclic quadrilateral, okay? You don't even know that it's a cyclic quadrilateral because, well, you know it's not a cyclic quadrilateral because that's not lying on the circumference. These lie on the circumference, C, B, and A lie on the circumference. It even says A, B, and C lie on the arc, but what you don't know is, what you definitely don't know is, what you know for a fact is that O does not lie on the circumference because it's a center. So then don't think that we have a cyclic quadrilateral. But since I have the origin, this is what I'm thinking. All right, I'm just going to try and find a whole bunch of angles. So these two are meeting up at the circumference, and then they also meet up at the center. So if that's 33, then on that basis, this should be 66 because it's the angle at the center. And they're not asking us to like justify, so I'll just do that on the picture. So that's 66 degrees, and you can see how I got that angle. Okay, now another thing that I technically have is I can work out this angle quite easily because I've got an entire triangle, okay? And then using angle sum of triangle, this is just 180, take 122, take 33. Now 122 plus 33 is 155. So this leftover angle here, 155 plus 25. This angle here is 25 degrees, okay? That's what I've got, is 25 degrees. Alrighty, now that I've got that, I also can see the fact that look at this angle here. Look at angle OBA. Look at this angle right here. Alrighty, so what you need to appreciate, that angle OBA is, well, first of all, do you see that this is the radius and this is the radius? Can you guys see that? That's the radius, that's the radius. It's a little bit hard to see because they didn't give you the full triangle, but those are your two radii. And if those are your two radii, then each of these base angles of these isosceles triangles are equal. It's an isosceles triangle and the base angles are equal. So 180, take 66 divided by 2. What is 180? Take 66 divided by 2. 180, take 66 is 104, 114. 114 divided by 2 is 57 degrees. So that's 57 degrees, and that's 57 degrees. Alrighty, and then if that's 57, guys, how much is just this much? How much is just this only? I'm trying to think. Now we don't need to do that much. We're done. We're sorted. Now do you guys notice we have exterior angle of triangle? We have two interior angles, and we have the opposite exterior angles. So two interior angles and the opposite exterior angle. So 57 plus 25 is 82. So this here must be 82 degrees. And the question said without any reasoning. So there you go. There's a lot happening in that. There was a lot happening. But yep, angle BDC is 82 degrees. I did a lot and it was just a little bit hard to see because they didn't do the full triangle. But to be fair, then I didn't really do that much. If this was 33, then the angle of the center was double that. Then obviously I had the full angle inside a triangle, which helped me work out this angle here. And then obviously this was an isosceles triangle, and using an isosceles triangle, I was able to work out each of these base angles. So then once I knew what this was and once I knew what this was, I was able to just use exterior angle of triangle to find out what this one here was. Make sense? All right. Oh, I quickly saw that it says prove. Prove means I'm going to have to show full working, okay? Prove means I'm going to have to show full working out. Alrighty. A secant cuts a circle. A secant is a chord that extends like beyond the circumference. Alrighty. So secant cuts the circle O. A secant cuts the circle with center O at points M and N. Alrighty. So secant MN is extended beyond. Secant cuts a circle at points M and N. So let's just draw a secant, something like this. So there's points M, there's point N. So there's M and N. Okay, what else do we have? Secant cuts a circle with center O at points M and N. Secant MN is, the N is just here, in fact. N is just there. It says it cuts a circle, so there's N. And then luckily I was meant to extend it anyway. I just thought I was going to call that N because that was a secant, but it said it cuts the circles at points M and N. Mn is extended beyond N, just like I've done it, to point P, where it meets a line tangent to the circle at point Q, where it meets a line tangent to the circle at point Q. So I'm just going to draw something like this, so that I draw something tangent to the circle at point Q. Yep, so it's tangent to the circle at point Q, so that's point Q. Prove that the size of angle NPQ, prove that the size of angle, okay, now this is a proof, and it's got this angle here, this angle here, this angle here. So what I'm going to do is I'm going to call this one like X, I'm going to call this one Y, and this last one can be Z. All right. Now, I don't know what lines I'm going to have to construct, but let's have a look. We have angle NPQ is X. NPQ is X. So that's kind of this here. So NPQ is X. We have angle MOQ is Y. So O is the origin. So MOQ is Y. So definitely I want to create a line from here to here and a line from there to there. And MOQ is Y. And we have angle NOQ. All right, let's move this out of the way. NOQ is Z. So I'm going to have to create a line there. NOQ is Z. All right. Now, this question really doesn't tell us too much. It, again, really doesn't hold our hand. Alrighty. And I know I've got to prove this relationship, but I really don't care. I don't care what the relationship is. I'll just try and relate X, Y, and Z together. And if I've done everything correct, it should work out just fine. Alrighty. So NOQ is Z, so this is Z. Alrighty. Now, where to begin? Now, I know it's tangent, so if it's tangent, I better write the 90 degrees. Whether I use it, whether I don't know yet, but I better write down that it's like 90 degrees. We all know that tangent's always perpendicular to the radius, okay? So, and it says proof, so if it says proof, I probably got to like show a few things. So I'm not even sure if I'm going to use that yet. So let me just do the question first. I'll do the question first, see how it works out, and then I will like write it down officially. So what to do, how to relate things together. Now, you know what, I don't like this shape. It's like a quadrilateral, don't really love it. This almost looks like that arrow, except I don't have this bit here. So I guess what I'm trying to say is I think I have to create a construction here. I think so anyway. Alrighty, so let's see how I go. Remember, I'm trying to relate Y, Z, and X. I'm trying to put them all together. Okay, so there's the arrow that I was talking about. So if the angle at the center is Y, then the angle subtended at the circumference is half that. So this is Y over 2. Okay, so that's pretty easy. What else? I'm just thinking, guys. I'm just thinking that over here, if I can somehow come up with an expression for this and this, then I can easily say this plus this is Y over 2. So I just need to come up with an expression for this in terms of Z. If I can come up with an expression for this in terms of Z, then I've got a relationship between X, something with Z's, and something with Y's. And then I'm confident that this will work out just fine. All right, so let's have a look. What do we have? Here it is. We have a radius and a radius. We have an isosceles triangle. That's all I really needed. And if I have an isosceles triangles, then each of these base angles are equal. So that base angle and this base angle, not that I'm really interested in that one. So this is 180 take z divided by 2. What's simplified version of 180 take z divided by 2? Really, that's 90 take z divided by 2. And if that's 90 take z divided by 2, then what does that make this angle here? That makes it, remember the whole thing's 90, so then this angle here is 90 take z over 2. 90 take z over 2, that just becomes plus z on 2. Excellent, I feel so good. I've come up with an expression for this, and an expression for that, and we know what this is. And these are the two interior angles that add up to the opposite exterior angle. So let's see what that gives us. So we have z on 2 is one of them, plus we have x is another one, and we know that all of this equals y on 2. Now I'm actually going to read my question. What is my question? Show that angle NPQ is equal to, okay, so fine, I have to come up with an expression for angle NPQ, so I've got to come up with an expression for x. That means x is y on 2, take z on 2, factorize out the half, and then what do we have? We have x is half, y take z. X is half, y take z. Oh, that's what I needed to figure out anyway. I had to show that NPQ is 1/2 the difference between angle y and z. Proven. Now that I've proven it, well, I've pretty much done the question. I just have to write it out. But see what I did? It's a little bit tricky knowing when to do what line, but I just trusted myself. I didn't worry about what I was trying to prove. I worried about trying to relate the three things that I was meant to relate together, and then things just fell into place. All right, so now let's just do the proof and write it out. So what information have I used? I guess I can write down angle QNM is half angle QON. So angle QNM is half angle QOM, which is half y, which is, and the reason for it is angle at center, double angle at circumference, double angle at circumference. I'll probably write at the start, I should have said something along the lines of let this be x, let this be y, let this be z. Okay, so right at the start I would have actually done let angle NPQ equal x, let angle MOQ equal y, and let angle NOQ equal z. So I would have done that like right at the start of the question. Alrighty, cool. So now that I've done that at the start of the questions, now I can go ahead. Okay, so I've got this. What else did I do? Oh yeah, I let this equal 180 take z on 2 because it was an isosceles triangle. So I'm just going to write down OQ equals ON equals radii, and because of that we can write down that angle ZOQ was non-Z, angle OQN was equal to 180 take z divided by 2. Alrighty, which was 90 take z on 2. Yep, we simplified that to 90 take z on 2. And the reason for this one was base angles of isosceles triangle. Base angles of isosceles triangle. Alrighty, what else did we have? Oh yeah, we had this is 90 degrees. So angle OQP was 90 degrees. Angle OQP was 90 degrees. And the reason for that is tangent perpendicular to radius. A tangent is always perpendicular to the radius. Alright, which meant this was easy to find out. Angle NQP, angle NQP. Angle NQP was therefore just 90 degrees. Take away 90 take z on 2. Probably a good idea to write degrees here. So 180 degrees, 90 degrees, take z on 2. So it was 90 degrees minus 90 degrees, take z on 2. The 90 crossed out, and we just got left with z divided by 2. All right, and lucky last, I think I used exterior angle of triangle. Yes, I did. I said this plus this equals that. Here, I did this. Z on 2 plus x equals y on 2. The reason being exterior angle of triangle. The reason for this, exterior angle of triangle. And then it worked out. That's how our proof worked out just perfectly. All right, that's how our proof worked out just perfectly. And that's how, some space. That's how I was able to write down. Therefore, angle, let's just write down angle NPQ. Therefore, angle NPQ is half the difference between the two angles that they asked for. So it is equal to half, equals half. Angle MOQ, angle MOQ minus angle NOQ. Yep, that's it. Proven for 4 marks. All right, well done. That's the end of Calc 3.